Hello students, welcome to another session on limits. In this session, we are going to look at some properties of limits and we are going to calculate the limit of a function using these properties. Let's look at the properties. Three major properties have been listed here. The properties are like this. Let us assume that there are two functions f of x and g of x, and that the limit of both these functions exist. They can be anything. They can be, let's say they can be the limit of f of x is L and the limit of g of x when x tends to a is m. This is the assumption that these limits exist. Now, what are the properties then? The first property says that if I have to find the limit of sum of these two functions, that is equal to the sum of limits of these two functions. That's the property. Okay, so limit of sum of the function is same as the sum of limits of the two functions. So if the limit of f of x is L and the limit of g of x is m, this would be L plus m. That would be our answer. This is the first property. Same thing goes for subtraction. So if let's say I have to find out the limit of a function f of x minus g of x, f of x minus g of x, what is the limit of this function when x tends to a? This is our question. Okay, so how will we figure this out? This will be according to the first property. See, individual limits of these two functions and you put the subtraction sign in between. So this is same as limit of x tends to a f of x minus limit g of x. Okay, again x tends to a. This is same as L minus m. Now both these subtraction and addition rules I've listed together, and that's why we've used plus minus sign. As you can see here, I've used plus minus sign together. Okay, so rule number one or property number one takes care of both addition and subtraction. Now, how to find the limit of a function where we have product of two different functions? So if I have product of f of x and g of x and I have to find out the limit of this product, the limit of this product is going to be product of limits. That's the second rule, that's the second property. So in terms of L and M, it's going to be L times M. Okay, because L is the limit of this, M is the limit of this function g of x. All right, similar thing goes for quotient as well. So if I have to find the limit of the quotient of f of x and g of x, that means if I have to find out this thing, it's quotient of limits. So limit of quotient is equal to quotient of limits. That's the third property. So we've taken care of multiplication of two functions, and we've also seen what is the property relating to division of two functions, right? There's one important thing to note here. Whenever we are applying the third property or the third rule in finding the limit of quotient of two functions, we need to ensure that limit of g of x cannot be 0. So this is a very important condition, because if limit of g of x is 0, then this entire limit, then this entire thing will be undefined. We cannot define it, okay? And that's why this is an important condition. All right. Now, then you will say, what's the proof of all these things? Well, the proof of this is currently out of scope for this session. but we are going to cover the proofs in upcoming sessions later. Okay, for now, all I can do is at least I can show you that these properties, these laws work. So what we'll do is we'll verify it. So if you remember in the last class, we saw how to find limits of functions when graphs were given, when their graphs were given. We'll use graphs to verify these properties. So I've chosen the multiplication property here. Give me a moment, students. Yeah. So I've chosen the multiplication property here. I have two functions, f of x and g of x. F of x is equal to x plus 1 and g of x I've taken as x square. I've plotted them. This is the graph of f of x and the second one is the graph of g of x. Okay. Let's find out what is the limit of f of x for a chosen point. Can you find the limit of f of x when x approaches 2? What's the limit? Let me see if I can help you out here. See, can you note what's the limit when x approaches 2? See, when x approaches 2, when x approaches 2, the value of f of x approaches 3, the number 3. So that's our limit. Okay, this is the limit. All right, so I can write that limit of f of x as x approaches 2 is equal to 3. We can see this, we can observe this from the graph. We can also substitute and see, but we'll look at that part later. Okay, for now we know the graph method, so we are sticking to that. Let's move on to g of x and let's find what is limit of g of x as x tends to 2. Well, from the graph you can see, let me draw these straight lines and see if I can help you figure that out. Yeah, if you look at this, if you look at this, you will find that this is equal to 4. Limit g of x as x approaches the number 2 is equal to this. So we've figured out individually what was the limit of g of x, what was the limit of f of x at the point x equal to 2. Now the rule that we just studied, the property that we just studied, it says that if I have to find out the limit of a function which is a product of f of x and g of x, so if the question says, if the question is, find limit x tending to 2 of a function which looks like this, x plus 1 times x square. So find the limit of this function. How would you do that? Now, the property says that individual limits of these two functions, you find those first. We found those limits, and then you multiply those two. So essentially this should come out to be 3 into 4, that is 12. That should be our answer according to the property. I've just applied the property here and I figured out that 12 should be the limit. Let's see, is it actually the limit of this function? Okay, so now I have the graph of the third function, which is f of x into g of x. This is this function. The graph is plotted. It's a cubic polynomial, and that's why you see, okay, it will have zeros at x equal to -1 and x equal to 0. There is a very little cusp here. You are not able to see that because it's so it's something like this. Okay, that's how the graph looks like. Anyway, what is the limit this function approaches, what is the limit of this function when x approaches 2? We have to find that. Okay, so let me draw a straight line from here till here and see what am I getting. So if I do this, I'm getting something like this. Okay, so this is 10, this is 10, this one will be 11, this one would be 12. Okay, so from the graph also it's evident that the limit of this function, which was a product of f of x and g of x, is, what is the limit? 12. The property also said the same thing, right? The limit of the function is 12. So we can at least see that this property works, this rule, this law works. Similarly, for now, you take my word for it, you take my word that all the three properties work. We are going to prove it later, okay? Don't worry, we are going to prove it later. All right. Let's use this property and try to figure out the answers of these questions. So take 5 minutes, pause this video, try to find out the answer to all these 4 questions, and then resume the video. Okay. All right. I believe all of you have given this an attempt at least. Let's start solving. We're going to solve part B first, then C, then D, and finally we're going to look at part A. I'll tell you why. Because from the 3 properties that we discussed just now, it seems that subpart B, C, and D are exactly those things, but we never saw what is the property for this, how to solve this. That's why we are going to take it up a little later. Okay. Let's get started with option B or subpart B. Limit of f of x when x tends to a number c is given to us. Limit of g of x is also given to us. So what would be the limit of f of x plus g of x? You first write it like this. This is limit of x tending c f of x plus limit of x tending to c g of x. Okay, this is an important step, and this is equal to, now you can substitute this. Okay, we know that limit of f of x is 3 by 2. You write 3 by 2 here. G of x is 1 by 2. This thing is 1 by 2. Okay, so 3 by 2 plus 1 by 2, 4 by 2 equal to 2. So this is the limit of this function. I'm going to clean the slate. I'm just going to keep the answer and clean out everything else. Yeah. Let's look at subpart C. Limit of x tending to c f of x into g of x. This is a function. You can even name this function, okay, if you want. If you're so inclined, you can call it h of x, where h of x is equal to f of x into g of x. We can do that. For now, it's not needed, so I'm just going to delete that. Okay, use the property. How can we write this thing? We can write it like this. Limit x tending c f of x. This is what the property says, right? Is equal to limit of x tending c g of x, isn't it? We all know that this thing is 3 by 2, and we know that this thing is 1 by 2. So 3 by 2 into 1 by 2, that's 3 by 4. That's your answer. 3 by 4. Okay. I hope this is clear how we figured this out. Let me just keep the answer and remove everything else. We've seen that the answer is 3 by 4, so I'll just keep the answer here. Similarly, for option number D, there was a condition, if you remember, that limit of g of x should not be 0, which is satisfied. We all can see that limit of g of x, it's not equal to 0, so we don't have any problems. We can still apply the property here to find out the limits. Let's do that now. Limit of f of x upon limit of f of x upon g of x. You can call this entire function as p of x if you are so inclined. So we have to find out the limit of p of x. How do we find that? Use the property, the third property, which was limit x tending to c f of x upon limit x tending to c g of x. So using the property, I can write this. Let me remove the unnecessary markings here. Okay. So this thing can be written as this thing using the property. Using the property. All I have to do now is substitute the values. So limit of f of x as x tends to this number c is 3 by 2. And what is the limit of g of x as x tends to c? It's 1 by 2. This way it gives me the answer as 3. So we know that limit of f of x into f of x divided by g of x, this function, is equal to 3. Let me clear this area because we want to solve the first question also. See, even though I did not explicitly tell you that there is a rule about multiplying a constant with a function, how to figure out the limit of such functions where a constant is multiplied with another function f of x, I did not explicitly state any rule for this. But actually this is included in the rule for product. What I mean by that, this rule you can apply here. Whatever rule we applied for subpart C, the same rule can be applied for subpart A. It's just that here my g of x is a constant. Okay, let me not call it g of x because we already have a g of x here. Let me call it h of x. It's a constant. Okay, h of x is a constant. So now solving subpart A. Limit as x tends to this number, I have a constant multiplied with f of x. Using the property of product of two functions, you can write this as this is equal to limit of x tending to some number c, this function multiplied by limit x tending c f of x. We can write this, yes or no? Think for a moment. We can, of course, we can absolutely write it like this. Limit of a constant function, no matter whatever the value of x you take, the value of y is always going to be 4. So limit of a constant function is always going to be the same number. What about limit of f of x? Well, we can see it's given in the question. Limit of f of x is nothing but this number, 3 upon 2. With this, we get the value as 6. So this is 6. If you want, you can take a screenshot of the solution because I'm going to clean it up. Let's move on now. We are going to do one more exercise on finding out the limits of functions using properties. But this time we're going to use graphs. We're going to use graphs to figure out the limits of individual functions. And then we're going to figure out the limits of product of functions or sum of functions or difference of functions. Take a look at this question. You all know how to figure out the limit of any function if you have the graph. We did that in last session. Okay, so take a moment, take 5 minutes, pause this video, attempt these three questions, and then come back to the session. Okay. Okay, I believe you all have given it an attempt at least. Let's get going. In the first question, we are finding out limits at this point, x equal to 2. This is my function f, this is my function g. First, let's find out limit of f of x when x is approaching this number 2. Can you find this using the graph? Can you find this using the graph? When x is approaching this point, well, I see that the value of this function, that means the value of y, is 0, isn't it? When x is 2, y is 0. So this is 0. We can see that from the graph. What about limit of g of x when x is approaching the same number, 2? When x is approaching this, that means this is going to be the value of limit of g of x. And what is this number? It's minus 1. Okay, so we figured out the limit of f of x at x equal to 2 and g of x at x equal to 2. Using the property, limit of f of x into g of x is equal to limit of f of x multiplied by limit g of x. Okay, of course, x tending to 2, x tending to 2 in both the cases. This is 0 multiplied by minus 1. This will give us 0. So that's our answer. Pretty easy, right? Using the graph also. We also saw it when direct values were given. Let's look at example 2 or question number 2. This time we are trying to find out limits at the point x equal to 1. So what happens to f and g? What happens to f and g when x is approaching this point 1? Okay, so there's a lot of clutter, so I'm going to clean this up, and then we are going to start afresh with second question. Okay, well, we did figure out already the answer to the first question, so I'm just going to write that here. Let's look at the second question now. This time we are looking at the point x equal to 1. What is the limit of f of x when x is approaching 1? You give me this answer, also give me the answer to this. What happens to g of x when x is approaching 1? When x is approaching 1, f of x, which is this function, it's quite interesting. f of x, the limit of f of x, if you look at it, if you approach this from the left hand side and from the right hand side, you'll see that the limit of f of x does not exist. Why? Because the left hand limit, so we have to find this, right? So left hand limit, if you're approaching 1 from this side, the left hand limit is this number. And if you're approaching it from the right side, the right hand limit is this number, -1, -1. So we can see that limit of f of x does not exist. Okay, this limit does not exist. Interesting. Does this mean that limit of f of x minus g of x also does not exist? We'll answer this in a while, okay? We'll answer this in a short while. Let's figure out what happens with g of x when we are approaching x equal to 1. When we are approaching x equal to 1, see, g of x is, of course, I can see it's defined, and the value that it is taking is 0. The value it is taking is 0. So, okay, limit of g of x is 0. But what can I say about the limit of f of x minus g of x? Since the limit of f of x I figured out does not exist, can I say that the limit of f of x minus g of x also does not exist? Can I say that? Well, you would be tempted to say that, but that's not always true. To figure out whether this limit exists or not, we'll have to approach this from the left hand side once and then from the right hand side. Okay, let's try to find out this limit from the left hand side. So what we are going to do now is we're going to find out the left hand limit, and then we are going to find out the right hand limit. What is the left hand limit? How do we write that? We write it like this: limit x tending to 1 minus f of x minus g of x. Okay, this is my left hand limit. Limit x tending to 1 plus, this is the right hand limit. That means we are approaching it from right hand side. This is what we have to find out. Okay, using the property, I can always split it like this. This can be written as limit f of x minus limit g of x. Limit f of x, when we are approaching 1 from the left hand side. When we are approaching 1 from the left hand side, this thing is, what is the value? What's the value? It's 2. Minus, well, limit of g of x was 0, so 2 minus 0. This is the left hand limit. Similarly, let's figure out the right hand limit now. Right hand limit, this I can write as limit x tending 1 plus f of x minus limit x tending 1 plus, that means from the right hand side, of g of x. Well, limit of x tending 1 plus f of x from the right hand side was -1, and that of g of x was this. So these two are giving me two different values, aren't they? 2 and -1. So we say that the limit of this function does not exist. Why? Because the left hand limit and the right hand limit are different. The left hand limit and the right hand limit are different. Now, I know many of you would say, when we just found out that limit of f of x was non-existent, why did not we directly say that limit of this function will also not exist? Why go through all this and then claim that limit does not exist? Why do that? I'll show you the reason, because in the third question you will see that even if, let's say, limit of one of the function does not exist at that point, a combination of functions, that is fx plus gx, might exist. Okay, and this would be one case where one of the limits does not exist at that point, but the limit of this entire function f of x plus g of x will exist. You will see that right now. Let me clean this up and then we'll start with the third question. Okay, I'll quickly write down the answers that we found out already. This was 0, limit does not exist. What about the third one? Okay, this is what we have to find out. So, but this time we are looking at the point x equal to minus 2. That means this point. Again, if you look at this point, limit of f of x when we are approaching minus 2 from the left hand side. What is the limit? The limit is 1. So limit of f of x when we are approaching minus 2 from the right hand side, this is equal to, when we are approaching minus 2 from the right hand side, let's see what's happening. When we are approaching it from this side, we're getting this. It's this number. Okay? Let's figure out the limit of g of x. Limit of g of x when we are approaching minus 2 from the left hand side, and limit of g of x when we are approaching minus 2 from the right hand side. What are these values? What are these values? We are going to figure that out. I'll state this again. Okay, so now we are going to find out the limit of g of x from the left hand side and then from the right hand side. When we are approaching g of x from the left hand side, when we are approaching minus 2 from this side, you see what number are we getting? So the left hand limit of g of x is 3. What about the right hand limit of g of x? At x equal to minus 2, when we are approaching this from this side, we're getting this value, that is 1. All right. So whether the limit exists or not for this thing. See, even if we saw that individually the limit of f of x does not exist at x equal to minus 2 because these are different. Limit of g of x also does not exist at x equal to minus 2 because LHS, left hand limit LHL, and R, right hand limit RHL are different for both these numbers. So individually the limits of f of x and g of x do not exist. But we'll now see that the limit of this combination exists. How? So let's find out the left hand limit of this combination first. Left hand limit of this combination would be limit x tending minus 2 from the left hand side f of x plus limit of g of x. I've used the property already, okay, to find the left hand limit. If we do this, What are the things we're choosing, we're picking? The left hand limit of f of x is this number. The left hand limit of f of x is 1. And the left hand limit of g of x is this. So 1 plus 3, which is equal to 4. So we can see that the left hand limit of this entire function is 4. So I'll clean this up and write it directly now. We figured out that left hand limit of this combination of functions is 4. What about the right hand limit? Right hand limit. To find that, you pick the right hand limit of this, which is 3, and the right hand limit of g of x, which is also coming out to be 4. That means limit exists, limit exists, and is equal to 4, because both the limits are the same. So what did we see here? Even though individually limit of f of x did not exist at x equal to minus 2, limit of g of x also did not exist at x equal to minus 2. But still, the limit of combination of these two functions exists at x equal to, or when x tends to minus 2. It's a very important point to keep in mind, students. So whenever you have a combination of functions, and when you find that one of those functions, the limit of one of those functions does not exist, don't make a hasty judgment and say that limit of this combination of functions also does not exist. That's not true. Okay, we've just seen, see, the limit of f of x did not exist at x equal to minus 2. Limit of g of x also did not exist at x equal to minus 2, because both the limits, left hand and right hand limits, were different. Yet, we saw that the limit of combination of the functions f of x plus g of x did exist, and the value came out to be equal to 4. I hope we understand this part.